Hey, this lecture is about control systems, and we will actually be covering block diagrams for the FE exam review. Block diagrams are used as schematic representations of mathematical models. The various pieces correspond to mathematical entities. They can be arranged to help simplify the equations used to model the system. Overall objective of this modeling is to obtain a mathematical representation in either a transfer function or a state variable form. The next few slides are of block diagrams and what the actual block looks like and what the function inside of it actually means. I'm not going to take the time and necessarily go through and read out what all these different symbols and everything are. What we're going to get back down to here is the third slide. It's called the feedback control system, closed loop. That's the one you're going to see the most. Many systems measure their output and use the measurement to control the system behavior. This is known as feedback control. The output is fed back into the system. The summing junction is a special process that compares the input and the feedback. Inputs to summing junction must have same units. It's just a little side note. So at the bottom you can see you have an input signal, the little circle with the crosshair in the middle, that would be the summing junction. You have a process, you have the output, and then out of the output you also have a sensor or a feedback that comes back to the summing junction. Okay, we're looking at a generic feedback control system. Input is the output we want the system to have. Summing junction subtracts the measured output from the desired output. The difference is the error signal. Controller acts based on magnitude of the error signal. The actuator provides an external power to system. The effects changes based on controller output. Plant is the process we are trying to control. This is a general model and may not be the same for every system. Systems can have additional inputs known as disturbances into or between processes. They can combine processes. Typically, controller and actuator are combined. Describe the draw a schematic, then recast your model into this form if possible. Here's an example of a cruise control system. You have an input, which is the desired speed. Your output is your actual speed. Your error is the desired speed minus measured speed. Disturbance, that'd be like wind, hills, etc. You have a controller, which is the cruise control unit. Actuator is the engine. Plant is the vehicle dynamics. Sensor is the speedometer. And so as we're going through the diagram at the bottom, we have the desired speed. You have your summing junction, cruise control, and then go to the engine, go to the vehicle, and in the vehicle you have a disturbance, which is your wind, your hills, and then your output, which is your actual speed, and then as you see at the bottom, it will go down, speedometer, and then some back in. Another example is a toilet flush example. We have the float height, which determines the water level. Flush empties the tank. Your float is lowered and the valve opens. Open valve allows water to enter the tank. Float returns to desired level and valve closes. Now let's look at another feedback control system. Figure 2 is an example of a block diagram showing a simple closed loop control system. The diagram details a controller and shows a plant with no detail. In the controller, the command U comes in from the left and has the feedback subtracted from it to form the error signal. The error signal is applied to the KP gain block and to the integer through the KI gain block. Then the results are added and applied to the plant, which responds with the output to the right of the diagram. And this is just another example of a block diagram. Feedback. A closed-loop transfer function in control theory is a mathematical expression describing the net result of the effects of a closed loop on the input signal to the circuits enclosed. The transfer function for the above diagram is y of s divided by x of s equals g of s over 1 plus g of s h of s. Transfer function. Here are different transfer functions. You have open loop, feed forward transfer function, control ratio, feedback ratio, error ratio, closed loop transfer function, characteristic equation, and then a closed loop poles and zeros if k equals 10. What this is showing you is the different transfer functions as they're broken down into their simplest form. So you can take a really big complex issue, problem, and if you keep breaking it down and putting the loops together and everything, you come up with these different transfer functions.